Good day, guys. This is your tutor engineer. Today we are continuing with graphs and motion in one dimension. So let's start with today's lesson. Jack is sitting in his Mini at a red traffic light. Just as the light turns green, he pulls away. A minibus taxi driving at a constant velocity at 20 meters per second passes him from behind. He accelerates uniformly at 0.7 meters per square second for 50 seconds and then drives at a constant velocity. The velocity time graph for the Mini and minibus is the following. So we are given the velocity time graph, and then the first question is, how long does it take the Mini to reach the same velocity as the taxi? So when they say how long, they're asking for time. You need to calculate the time where both the vehicles are driving at the same velocity. So they'll be driving at the same velocity here, right? So since their velocity time graphs will interface, that's why they cross. So we're gonna calculate that time. So we know that the coordinate here is 50 seconds and 35 meters per second, and then here the coordinate is t1, which is unknown. That's the one you're going to calculate, and then the velocity is 20 meters per second. And then remember, we're given the acceleration. The acceleration is 0.2 meters per square second. So in order to calculate the time, we're going to say, since we are given the velocity time graph, we need to calculate the acceleration. We'll calculate the slope. If you are given the velocity time graph, so we'll calculate the slope to get to the acceleration. So we'll say here the acceleration is equal to v2 minus v1 divided by t2 minus t1. So v2, we'll say 35 minus 20 meters per second. Likewise, t2 is going to be 50 minus t1. So t1 is unknown. So we've been given that the acceleration is 0.7. So we're going to calculate t1. So we're going to cross multiply this. Basically, we're solving for t1 now. So 35 minus 20 will be 15 divided by 50 minus t1, that is 0.7 over 1. So now let's cross multiply. So cross multiplying, 1 times 15 will give you 15, and then here you'll have 0.7 multiplied by 50 minus t1, which will be 50 times 0.7 will give us 35. So here you have 0.7 t1. Now we can take 35 to the other side. It will be negative. So 15 minus 35 is equal to 0.7 t1. So 15 minus 35 is minus 20. So remember, the minus 0.71, the sign here is minus, so the answer you say equal to 0.71 t1. So t1 is equal to, we'll divide by 0.7 negative both sides. So t1 will be minus 20 divided by minus 0.7. t1 is 28.6 seconds. So that is when they'll be driving at the same velocity. So here you'll have 28.6 seconds. Now let's go to question 2. Use the graph to calculate how far behind the minibus the mini is after 50 seconds. So when they say how far behind, that means you need to deal with the displacement. So for the mini, you're going to calculate the displacement. Remember, given the velocity time graph, and now you have to work out the displacement in meters. That means you'll calculate the area under the velocity time graph. So for the mini, the area is going to be this entire triangle. The base is 50, that's the total base. Then the height is 35 for that triangle. So we're going to say displacement is half base times height. Since it's a triangle area, the base is 50, the height to set is 35. So the displacement will be 50 times 35 divided by 2 is 875 meters in the positive direction. So that's the displacement for the mini. Then for the mini bus, we're going to be dealing with the area of a rectangle. So for the mini bus, this is the area of the mini bus, right? It has the same base of 50, but the height will be 20. So okay, let's calculate. The displacement will be base times height. The base is the same as 50 seconds. The height is 20. 50 times 20 is 1000 meters in the positive direction. So to answer the question how far behind, you're going to get the difference between the two displacements. So 1000 minus 875, that means the mini is 125 meters behind. That would be the answer. And then question 3 says sketch the corresponding displacement time graph of the mini and the minibus on the same system of axes. Okay, so we have the same system of axes. The time starts from 0. Here we calculated 28.6, and then here we're at 50. And then this is time in seconds. This we'll call displacement in meters. So for the displacement, we can count in 300s. Here you'll have 600, 900, and then here 1200. Okay, so let's start by plotting the mini. So the mini at 50 seconds, the mini is 875. So we'll just mark it. Here is 50 seconds. Okay, the mini at 50 seconds is 875, which is about here just below 900. So you'll have a point there for the mini, right? So remember the velocity time graph for the mini started by accelerating at a velocity, a certain velocity, up until it reached 35 meters per second, and then it became a constant velocity. So since it's accelerating in that way, we'll draw the graph as a half of the parabola. So the graph for the mini is not actually a straight line, is going to be like a parabola, like this, before it can start going straight at a constant velocity portion. Then it's gonna go straight. But between 0 and 50, it's like a parabola. It's not a straight line. So we'll say this is the mini. Now let's pick a different color for the mini bus. So we've calculated the displacement for the mini bus. At 50 seconds it's 1000. So here is 50 seconds, 1000 is just above 900. Is here 1000, so we'll mark a point here. Since the velocity time graph is constant for the mini bus, so the displacement is going to be a straight line from 0 going straight. Believe me, this is a straight line. Let's just correct it. So it's going to be a straight line from 0. So let's make sure it is as straight as possible. So it's even going to go past still as a straight line. So this is a mini bus until they interface somewhere where they are at the same displacement at a certain time. Okay, so this will be the graph for the displacement. So we've come to the end of our today's lesson. If you enjoyed today's lesson, please subscribe and stay tuned on the next lesson. Cheers.